in this video, we're going to take a look, find the mean and standard deviation for a normal distribution. So if we're given a random variable that is normally distributed, but the mean mu or the standard deviation sigma, or potentially both of the parameters are unknown, then we can use the standard normal distribution to find any of these parameters. So like I said, then the first thing that we need here is a random variable that is normally distributed. We've got x here that is normally distributed. Now what I can see for x then is the value of the mean here. This parameter is unknown. So if we have one parameter that's unknown, we also need one probability, like we've got here. So if we had a situation then where both of the parameters are unknown, we'd need two probabilities. Okay. So all we're asked for here is the value of the mean mu. So like we said, then we use the standard normal distribution here to find these parameters. So in that case then, we have a standard normal variable. Don't forget we use z to represent our standard normal variable. This is normally distributed with a mean of 0 and a variance of 1. So we just refer back to this probability here then. This is the probability that x, our random variable x, is greater than 12, and that's equal to 0.3446. So we're working with this standard normal variable here then. So what I need now is the probability our standard normal variable z is greater than, so the inequality follows the same here as what we've got for this probability here. This is greater than some value, say z, and that is equal then to 0.3446. Okay. So what I'm going to do now is use the inverse normal distribution on my calculator. So use inverse normal. We use inverse normal here. So the way to get to this on my calculator here is I go into stats mode. I then press distribution. I've got distribution. Once I press distribution, I then press normal for the normal distribution. I've got norm there for the normal distribution. And then finally, I press inverse n. So this is the inverse normal distribution. And then what I get asked for here is a few different things. So the first thing that I get asked for is the tail. So we get asked for the tail. So the tail here, this would either be left or right. So in this case then, we look at the inequality here. So this is greater than, so it's pointing to the right. So in that case then, my tail is right. If it was less than, it would be pointing to the left, and therefore the tail would be left. Okay. So that's the tail. We'll then ask for the area. So for the area here, nice and straightforward. That's just this value here. So 0.3446 there. We'll then ask for sigma. So that's the standard deviation here for our standard normal variable. So that would be 1. And then we'll ask for the mean here, mu. And again, nice and straightforward. That would be 0. Okay. Once you've got that, then just press enter. What this gives me now is the inverse normal value here. So I get x inverse. I get x inverse here. And what I get then is 0.39994096. So now if we just round this here to a sensible degree of accuracy, what I get then is 0.4. Okay. So we get 0.4 there. So now let's just go back then to the original probability here. This was the probability that x, this random variable x, is greater than 12. And that is equal then to 0.3446. So 0.3446 there. Okay. So we're now using this standard normal variable here. Okay. So what we're saying then is the probability that our standard normal variable z. And don't forget what we're going to do now is use our coding here for the standard normal distribution. We're going to use the coding here. And don't forget we established this in the previous video on the standard normal distribution. We use the coding here, z equals x, our random variable x, minus the mean mu. We divide this here by sigma, the standard deviation. Okay, so this is the coding that we're going to use here. So z is greater than, so it's x. So that is 12. That's this value here. So we've got 12 minus the mean. Now I don't know the value of the mean. That's unknown. So I do 12 minus mu there. And this is divided then by sigma, which is 5. I divide that by 5. And this here then, this is equal to the same value. So this is equal to 0.3446. Okay. So now what I've got here is 12 minus mu over 5, but this is equal then to this x inverse value. Okay. And from here then we can now easily find the value of mu. So therefore 12 minus mu all over 5, that is equal to 0.4. Okay. So we're just looking to solve for mu here, so I'm going to times both sides by 5. So we get 12 minus mu is equal to 5 lots of 0.4. 5 times 0.4 is 2. So here I've got 12 minus mu is equal to 2. So therefore, nice and straightforward, mu would be equal to 10. Okay. And there we have it. So that gives us the solution there to question 1. If we take a look then at another example here, this time now where we're looking to find the value of the standard deviation. So we've got our random variable x here that is normally distributed. And in this case here, the standard deviation or the variance is unknown. And we're given 1 probability here. So to find the value of the standard deviation here, again, we just use the standard normal distribution. So we need our standard normal variable, in this case z. This is normally distributed with a mean of 0 and a variance of 1. So here, the probability that x is less than 10, that's equal to 0.7475. So what I need here then is the probability that our standard normal variable z is less than some value, let's say little z, and that is equal then to the same value here. So that's equal to 0.7475. Okay. So now what I'm going to do here is use the inverse normal distribution on our calculator. So use inverse normal. So use inverse normal then. And again, we're asked for a few different things here. The first thing that I'm asked for is the tail. So the tail here, again, that goes back to the inequality here. So because it's now less than, the inequality is pointing to the left, so my tail is left as well. So that's left. For the area, nice and straightforward. That's just whatever this is here, so that's going to be 0.7475. Then we've got sigma here, the standard deviation, that's 1. And then the mean mu, that's equal to 0. Okay. Once you've done that, press enter. And now what I've got here is x inverse. So therefore, x inverse here, that is equal then. So I get 0.6666433. So in that case then, if I round this here, let's say to 0.667. Okay. Or you could keep it as 0.6666. Doesn't really matter. You will get the same answer either way for the value of sigma. So what we've got there is x inverse. So now we go back to the original probability here. So we've got the probability our random variable x is less than 10. That is equal to 0.7475. Okay. So now for the standard normal variable here, what I've got then is the probability. So this is for our standard normal variable z. And again, don't forget when you use the coding here. So use coding. So I've got z. That's equal to the random variable x here minus the mean mu. And we divide that by standard deviation sigma. Okay. So z here, well, this would be less than. Notice the inequality follows the same here for here. It's going to be x, so that's 10, minus the mean, which is 8, so 10 minus 8 there. And we divide this here by sigma, which is unknown. Okay, so we divide that by sigma. And this here then is equal to 0.7475. And once we've got to this stage here, then we've done all the hard work. We're pretty much there now. So at this point here then, what we've got here is 10 minus a over sigma, and that must be equal then to x inverse. Okay, so therefore 10 minus a all over sigma, that must be equal then to 0.667. Okay, so all I need to do then is solve for sigma here. So I get 2 over sigma. So 2 over sigma is equal to 0.667. So obviously what you could do here is you could just take the reciprocal. That would be sigma over 2, and that's equal to 1 over 0.667. Or you can just times 3 by sigma. Either way is fine. If I just times 3 by sigma then, I get 2 is equal to 0.667 sigma. Okay. And then finally, we just divide through by 0.667 here. So therefore, sigma is equal to 2 divided by 0.667. What I get here then, if I round this to a sensible degree of accuracy, is I get 3. Okay. Basically, 2 is being divided here by 2 over 3. So 2 divided by 2 over 3, it's the same as times in 2 by 3 over 2. And I get 3 there. Okay. But there we have it. So that gives us the solution there to question 2. So if we just take a look now at the last example here, where we're looking to find the value of mu and the value of sigma. So what I've got here is 2 unknowns. We don't know the value of the mean. We don't know the value then of the standard deviation. This is certainly the trickiest type of example you'll get here for these mean and standard deviation questions for the normal distribution. However, it's not too challenging. Basically, all that happens here is we form simultaneous equations. Okay. So again, we're going to use the standard normal distribution here. So we need our standard normal variable. We have z, which is normally distributed with a mean of 0 and a variance of 1. So what I've got here then is 2 probabilities because we have 2 unknowns. So I've got the probability that x is less than 4, and I have the probability that x is less than 22. So using our standard normal variable here, what I've got then is the probability that our standard normal variable z is less than some value, let's say z1. Okay, that's equal then to this probability here, so 0.1056. And I've also got then the probability that our standard normal variable z is less than some value, let's say z2, and that is equal then to this value here. So 0.8413 there. Okay, so let me just redo that 8. It's a little bit messy. Try it again. So 0.8413. Okay. So here what I need to do now is use the inverse normal 2 times. So we're going to use the inverse normal then. So use the inverse normal. So to begin with then, if we do it for Z1 here, so for Z1, this is the probability then our standard normal variable Z is less than Z1, and that is equal to 0.1056. So using the inverse normal then on our calculator, again, we're asked for a few different things. So I've got the tail here. So in this case, it's less than, so the tail is pointing to the left, the inequality is pointing to the left, so the tail is left. For the area, again, nice and straightforward. That's just this value here, 0.1056 there. For sigma, that would be the square root of 1 squared, so that's just going to be 1. And then the mean is 0. Okay, press enter here then. What you get then for x inverse, so therefore x inverse here, we get minus 1.25. Okay, so minus 1.25 there. And now we use the inverse normal here for Z2. So for Z2 then, so this is the probability that our standard normal variable Z is less than Z2. That would be equal then to 0.8413. Okay. So from here again, I need these different requirements. I've got the tail. Again, this would be left. It's pointing to the left here. the area, remember that's just this value here, so that's 0.8413. We then have the standard deviation here. So again, the standard deviation for a standard normal distribution is 1 and the mean is 0. And then again, I just press enter here. And this gives me x inverse. So if I do that on my calculator here, just dead quick, what do I get? So the tail is left, the area is 0.8413, the standard deviation is 1, and the mean is 0. So in that case then, for x inverse here, what I get is 1. Okay, if I round that to 1 there. So now, we've got x inverse here for z1, got x inverse here for z2. So now we go back to the original probabilities here. What I've got then is the probability that x is less than 4, and that's equal then to 0.1056. Okay. And now we're going to use our code in here for the standard normal distribution. So what I've got then is the probability that z, our standard normal variable here, this is less than, it's going to be 4 minus the mean, which is mu, and that's all over sigma, because again, we don't know the mean or the standard deviation here, and this is equal to this value here, so 0.1056. So in this case here then, 4 minus mu over sigma must be equal to minus 1.25. That's equal to x inverse then for z1. So therefore, 4 minus mu over sigma is equal to x inverse then for z1. So that's minus 1.25. Okay. We're now going to repeat this here for z2, this probability here. Okay. The probability then that x is less than 22. That's equal to 0.8413. So again, if we use our code in here and our standard normal variable, this is the probability then that z is less than, so x is 22. Again, we don't know the value of the mean or the standard deviation here. So it's going to be 22 minus mu, and that's all over sigma. Okay. And again, that's equal to this probability here. So in that case then, 22 minus mu over sigma must be equal then to this x inverse here for z2. So therefore, I've got 22 minus mu over sigma, and that must be equal then to x inverse for z2, which is 1. Okay. So we're on the right path here. We're doing quite well. What I need to do now is basically form my simultaneous equations here. So for this equation here, what I'm going to do is I'm going to times through both sides by sigma. That's what I get here then. I'm going to get 4 minus mu. So 4 minus mu there, and that's equal to minus 1.25 sigma there. Okay. Then we do the same here for this equation here. What I'd get then is 22 minus mu, and that's equal to 1 times sigma, which is sigma. Okay, so all I've done there then, just in case you were confused, I just times through both sides by sigma here for this equation and for this equation here. So now it's up to you how you go about solving this here. Whether you do substitution, whether you do elimination, either method's fine. So if I make mu the subject here for both of these, okay, so in that case then mu is equal to 4 plus 1.25 sigma. Okay, so I've made mu the subject there, add mu to both sides and add minus, or add this to both sides here. That would make it positive. So I get mu there. Doing the same here then, if I make mu the subject, I get mu equals 22 minus sigma. Minus sigma there. Okay. And because I've now got these two equations here where mu is the subject, I can now make these equal to each other. Okay. If we do it underneath in a different color, just so you can see it clearly, let's do it in red. What I've got then is 4 plus 1.25 sigma. So 4 plus 1.25 sigma. That is equal then to 22 minus sigma. Okay. So here we just need to solve now for sigma. So I'm going to add sigma to both sides. I'm also going to subtract 4 off both sides. So I get 2.25 sigma. And that is equal then to 18. And then finally, if I divide both sides now by 2.25, I get the value of sigma. So therefore, sigma here, that is equal then to 18 divided by 2.25. So quickly do that on my calculator. What I get then is 8. So the standard deviation here is 8. But we're not done here. We also need the value of the mean then, the value of mu. So we can easily find that then by using either of these rearranged equations. If I use this one, it's a little bit easier. So therefore, for the mean mu, that is equal to 22 minus sigma here. So sigma is 8. So 22 minus 8 there. And what I get then is 14. Okay, so the mean then at mu is equal to 14. And there we have it. So that's the value of the mean. Let's just highlight that here. And this is the value of the standard deviation sigma. Okay, and there we have it. So like you can see, mathematically nothing too challenging. It is just literally forming simultaneous equations and then solving those simultaneous equations. However, the work before it can be a little bit more complex, like you can see here, getting both of those inverse normal values and then forming these equations here. But there we have it. So that gives us the solution there to the very last question, question 3. That brings the end of this video on finding the mean and standard deviation of a normal distribution.